Hello once again. This is about your 3D printer. You've printed a calibration cube. You've got your printer lovely and level, both in this direction as well as this direction. Right. You've got the printed bed all sorted out, it's all working perfectly fine. You want to print objects. Printing objects has a width, a depth and a height, but it also has an internal volume. So you've got to decide the infill. Here are various infill densities. This one here is 10%. Right? As you can see, it has a few pieces. This is called the infill. That's the outer edge, right? And that's the infill. Now, with a small object like this, it's quite weak. But for a large object, that would be more than strong enough to support the external volume or the external shape from compression forces. That's only 10%. As you can see, it's still quite hollow, so you're not using that much filament. For a large object, I suggest you might use, say, 10%. It will still make the object very strong, even though at 10%. For smaller objects, 10% infill is fine, but it can be easily squashed. This here is 20%. True, it's backwards, but you know what I mean. This is 20%. Again, the gaps in between are half this size. So for each square, there's 4 little squares in this one. And that's 20%. So it's a lot more denser, a lot more stronger. But again, you're using a lot more filament. But that's for smaller objects. I'd say no more than about, what, 6 inches by about 6 inches. Because if you did a 6-inch cube with this stuff, you'd be using at least half a roll of filament. But it's the object you're printing, it depends on what you're going to be using it for. If it's for support of some other item, then 20% is fine. If it's just for show, then 10% is fine. But if you want objects with high strength, the infill has to be more dense. As I said, that's 20%. And this one is 40%. Right. 30% is just in each little square. There's 4 other squares in there at 30%. This one is 40%. As you can see, it's incredibly dense. All right. Here's a comparison. That's 40%. That's 10%. Now compare the difference. You're using 8 times the filament in this one than you are in this one. Now for a very small object, that's fine. But for a large object, using this type of infill is not good, because you'd be wasting so much filament to infill a large object using this infill pattern, which is 40%. And that's 10%. So for a very large object, 10% is more than strong enough, so long as your printer has been dialed in and you've printed in the first one a calibration cube. And you've got the print bed perfectly level, the temperatures for the PLA absolutely perfect for the settings that you're printing at. So it has a nice smooth surface, both the underneath as well as the top, which means it shows that the nozzle was very level when it printed this calibration cube. And you can see there's a slight pattern on it. That's not because of failed printing or anything wrong with the printing, it's how the nozzle prints. Remember, the nozzle prints lines. Right? So for a square, it might print the external diameter, right? Then it goes across this way, then it might go this way. Right? It depends on how the slicing software has sliced the object to print the various layers. It's not just layers this way, right? There's also layers this way as well. Right? 'Cause it just doesn't go, it does like this, a pattern, right? And it fills in the pattern, does the outer edge, does then details. So if you've got anything that sticks out from the object, it has to first of all print around that height of the object, and then start printing the height itself. But that's a calibration cube. You must print one of these, or actually 5 of these first. One in each corner, one in the centre. Because some print beds can be bowed just a little bit, but enough to make a difference. And again, that's 40% infill. That's 10% infill. This one is 50% infill. 40, 50. So for an object that has quite high strength properties, especially for PLA, 50%. Now if you're using something, an exotic filament like PETG, carbon fibre, nylon, 10% would make the object quite strong. This one's broken here slightly. That's because I haven't bothered to mess about with it and it's just got damaged through wear and tear. But it's not foul printing, it's just because I haven't stored it very well. But for high strength objects, 50% infill, as long as it's not too big, would be perfectly fine and make the object incredibly strong. But you could stand on it, it'll be that strong. Right? Especially for things like PETG, nylon, especially carbon fibre filament. But they're expensive. Right? But an object with this much infill would be incredibly strong. In fact, people have printed carabiners out of carbon fibre filament. And they're just as strong, right, as their metal counterparts. This is 60% infill. As you can see, 50%, 60%. Not much difference, right, but slightly tighter pattern on here than it is on this one. But for objects that require extremely high strength, and maybe it might have lots of details, this is perfectly fine. But again, you're using a lot of filament in the internal volume. See, this is the external perimeter of the object. This is the internal volume. Right? And for this little cube, it's not so bad. But if you've got a shape that's about this big, by about this big, by about this big, right, you'll be using at least a third of a reel of filament just to print. And it might take at least 9 hours plus to print. But that's only if you want extremely high strength. You can use infill if you're using a particular slicing software in different areas. So the main body might be 10%, and say in the arms of the object, say 40%. And then in places where you need high strength, 60%. Then this one is 70%. See? 60, 70. As you can see, it's getting almost solid now. Right. The holes are extremely fine. But again, high strength. Right. After about 50%, you're talking about high strength objects, right, who require very high infill densities, which is tied with high strength. Right. Low objects of medium strength, 10, 20, 40. I've lost the 31, so there should be one in between this one and this one, but I've lost the 31. Right. Again, this was only a test of my infill pattern for my printer. Right. So I suggest when you get yours and you're setting it up, you do an infill test. So you get a cube which has no infill. In your slicing software, you select infill. You then select density. There's 10, 20, 30, or whatever number you want to type in. But I suggest you do it in 10, 20s, 30s, 40s, in steps of 10. So you get a nice range of infill patterns. So you can then decide which one you want to use for your object, depending on what you're printing. This one is 80%. This is 70. This is 80. As you can see, it's getting to be almost solid now. The layer lines are almost touching. So this is almost a solid object. It is really strong. But doing a big object with this, you'd be using at least 3/4 of a reel of filament. And white filament is not that expensive. It's quite cheap. There's no point in wasting it if you don't have to. If you're printing small objects that require very high strength, 80%, so long as it's quite small, right? and that require high strength. Maybe an object, say, no bigger than this. Right? This is a pencil sharpener. But I won't be printing this because I won't buy this really cheap. But if you print an object that's, say, about this volume, right, then 80% infill for high strength. If it's critical that it requires high strength, then 80%. If it's an object to play with, maybe you're printing a figure as part of your D&D, or a figure for a collection, or something you're printing that doesn't require high strength, then 20% is more than strong enough to support the external perimeter as well as the internal structure. 50 to 80, very high strength. Right. 10 to 40, right, medium strength, but still quite strong, but medium strength. If you're going to print an object about this size, right, then either 10% infill, 20% infill. If it requires strength, but there's no heavy forces being used on it, then 40%. If it's this big, but it requires lots of external forces to be used on it, let's say you're printing a part for your 3D printer, and it requires strength, 50%. If it's a critical part and does require lots of torsional strength, that strength both in compression as well as extension, right, then 80%. 80% infill. If it's an object that has compression forces, right, 60%. It depends on what you're going to be printing. Right? If it's this big and it's just a play figure, 20% or 10%. If it's this figure and you're going to be using it quite well, then I suggest either 30 to 40. 40 is best, right? But again, you'll be using a lot more filament. But it depends on what you're going to be using the figure for. For high strength, high use, 80%. But the object is almost solid. In other words, the internal volume of your object will be almost solid. And you'll be using at least, for an object roughly that size, I'd say about an eighth of your filament, an eighth of a reel of filament for an object that size, printed at 80% density. See, because that's 80%. And here's the difference. That's 10%, that's 80%. This was a print test of infill, right? Well, just for my use and seeing how dense it is compared to, say, 10%, that's compared to 80%. Yeah, this is broken here, I know, right? But I don't really care about this. This was just a test of infill density. It wasn't a test of strength or a test of my calibration, because I've already done that with one of these. Actually, with 5 of these. So, 20, 40. All right. High use, low strength. High use, high strength, 50, 60, 70, 80%. For high use and high strength. You can go to 90%, but there's no point in us make it solid. Because it will literally be solid, because the layer lines at 90%, because this is 80, will physically be touching. And there's no difference between 90 and 100. Now you can print your filament at very fine line, 0.1. You can even get it finer if you want by changing a nozzle. If you print with, say, a 0.1 nozzle size, you can get the layer lines finer than a human hair. But you're talking about very, very, very slow speeds. You can't push filament through a very fine nozzle at that fine, at high speed. Right, this can print quite quickly, right? Like like this. But at a 0.1 size nozzle, it will print like this. Because you've got to push the filament out of the nozzle onto the bed, right, and adhere each line, right? Because you can change nozzles. You can get a 1mm size nozzle, a 2mm size nozzle, even a 4mm size nozzle, right? But that'll print a filament about as thick as this. In other words, it will come out of your machine this thick, say a 4mm nozzle. But you better see every single layer line. It will show as little tiny ridges. Right? It might look fine if you're going to do something really strange, like maybe a vase or a vase, how you want to pronounce it. But the normal size for a nozzle is 0.4. So with a 0.4 nozzle, it can print 0.1, 0.2, 0.3 and 0.4 size filament. And that's with a nozzle size at 0.4. And these are infill patterns. So, if you've got your printer and you're setting it up, calibration cube, first step. Right? Once you've got this sorted out, infill pattern, 10, 20, I've lost the 30, but there's 40, there's 50, there's 60, there's 70, and there's 80. So if I put them together, if I can pick them up without dropping them, no. And there they are. I just dropped one. Right. But that's from 10 to 80. I dropped the 51 down now. And but that's calibration cube. Step 1. Infill pattern. Step 2. And once you've got all these sorted out, you can then decide what infill pattern you're going to use for your object, depending on what strength it requires and how you're going to use it. If you're going to print a figure, can I suggest a simple 20%? If you're going to print a figure for, say, D&D, a 20% infill is perfect. Not too much, not too little, just the right amount of internal fill space. Perfect. For high strength and high use, 50. For very high strength and very high use, 80. But it's just PLA. Right? You can print the same thing in ABS. But these are infill patterns. And that's if you're going to, after you print a calibration cube, infill patterns, you know what you're doing, you know the steps of your printer, and you can have seriously happy printing and print lots of different things. Have fun printing!